Welcome to MRL. In this learning session, we'll learn the solutions of examples of exercise 6.3 of triangles chapter CBSE 10th textbook. Okay, so let us begin. Now I will start with the third example. The first two examples they are very simple and you can solve them yourself. Now example number 3, we are given a trapezium ABCD. AB is parallel to DC. Diagonals AC and BD intersect at point O. Now we have to prove that OA upon OC is equal to OB upon OD. So let us see the proof of this. In triangle AOB and triangle COD, angle 1 is equal to angle 2, that is interior alternate angles are equal because AB is parallel to DC and AC is the transversal, therefore angle 1 is equal to angle 2, interior alternate angles are equal. And again angle 3 and angle 4 are equal because interior alternate angles are equal again, and angle 5 and angle 6 are equal, that is vertically opposite angles. So therefore the three angles of the triangle AOB and triangle COD are correspondingly equal, and therefore triangle AOB and triangle COD are similar. When two triangles are similar, then their corresponding sides are proportional. Therefore we have OA upon OC is equal to OB upon OD is equal to AB upon DC, and that is what I have written here. And therefore taking the first two ratios here, OA upon OC is equal to OB upon OD, and that is what is the proof required, and we have proved it. Okay, remember that. Now coming to the next example, we are given a diagram here, a figure here. Now from this figure we have to prove that triangle PQS is similar to triangle TQR, and in this try to understand here, we are given that QR upon QS is equal to QT upon PR, and also we are given angle 1 is equal to angle 2. So let us understand how to prove triangle PQS is similar to triangle TQR. Now in triangle PQR, angle 1 is equal to angle 2. The sides opposite to these two angles are also equal. That means PQ is equal to PR, because we know the sides opposite equal angles are equal, therefore PQ is equal to PR. Now we are given QR upon QS is equal to QT upon PR. I can replace PR by PQ. So I have replaced PR by PQ because PQ is equal to PR here. Now if you observe here, QR upon QS is equal to QT upon PQ. Now PS is joined here. PS divides the two sides of the triangle QTR in the ratio QR upon QS and QT upon PQ, and therefore PS is parallel to TR. By converse of BPT. Now angle 3 is equal to angle 4. Since PS is parallel to TR, definitely 3 and 4 are corresponding angles, therefore they are equal. So also angle 5 and angle 6 are equal, corresponding angles. Angle 1 is common to both the triangles, and therefore the three angles of one triangle are correspondingly equal to the three angles of the other triangle. That means the triangle PQS, the angles of the triangle PQS and triangle TQR are correspondingly equal, and therefore by AAA similarity criteria, triangle PQS is similar to triangle TQR. So please remember this angle 1 is equal to angle 2 criteria, where once angle 1 is equal to angle 2, the sides opposite to them are equal, that is PQ is equal to PR. So by replacing PR by PQ, we could show or we could prove that triangle PQS is similar to triangle TQR. Remember that. Now coming to the next example, we are given a triangle PQR. S and T are the points on PR and QR. ST is joined. Angle P is equal to angle RTS. Angle 1 and angle 2 are equal here. Angle P is equal to angle RTS. Now we have to prove triangle RPQ is similar to triangle RTS. We have to prove that RPQ is equal to RTS, that is similar to RTS here. So let us see how to prove that. Now in triangle RPQ, and triangle RTS, angle P is equal to angle RTS, because that has been given to us. Angle P is equal to angle RTS, it is given, that is angle 1 is equal to angle 2. Angle R is equal to angle R, it is common to both the triangle, that is RPQ and the RTS. Angle R is common, therefore angle R is equal to angle R, that is common angle there. Now angle Q is equal to angle RST, that means angle 4 and angle 5 are equal. That means the three angles of the triangle RTS and the angles of the triangle RPQ are correspondingly equal. Therefore by AAA similarity criteria, triangle RPQ is similar to triangle RTS, and that is proved here. So that is what is the method of proving this particular example. Now coming to the next example, we are given a triangle ABE and ACD and they are congruent. Triangle ABE is congruent to triangle ACD. Please understand this. And then we have to prove that triangle ADE is similar to triangle ABC. Again I will repeat, triangle ABE is congruent to triangle ACD. We have to prove that triangle ADE is similar to triangle ABC. So let us understand this. Now triangle ABE is congruent to triangle ACD. It means that the corresponding sides are equal. That means AB is equal to AC, AD is equal to AE, and BE is equal to CD, because both are congruent there. Now in triangle ABC, DE is joined. In triangle ABC, DE is joined. BE divides, please understand this, BE divides sides, BE divides sides, not BE, DE divides, rather it is not BE, DE divides. So DE divides the sides AB and AC in the ratio AD by BD is equal to AE by C, AB by AD by BD and AE by CE. Therefore AD by BD plus 1, when I add 1, AD by BD plus 1 is equal to AE by C plus 1. AD, taking the LCM, AD plus BD by BD is equal to AE plus C by C. Now AD plus BD is AB, okay, AB by BD, and AE plus C is AC, so AC by C. Now we have got BD, taking the reciprocal here, BD by AB is equal to C by AC. Now subtract BD by AB by 1 and also C by AC by 1. So 1 minus BD by AB is equal to 1 minus C by AC, and taking the LCM again we get AB minus BD upon AB, AC minus C upon AC, or AB minus BD. AB minus BD is AD upon AB is equal to AE upon AC. Now here again AD is equal to AE, that is because the two triangles are congruent there, and AB is equal to AC because they are congruent. So now we have AD upon AB is equal to AE upon AC, because AD and AB are equal, AE and AC are equal, this and this will be equal to 1, that means both are equal. So therefore we have AD upon AB is equal to AE upon AC. Now by converse of BPT, if the line D divides the two sides in the same ratio, by converse of BPT, D is parallel to BC. Now if D is parallel to BC, that means the three angles of triangle ADE and the three angles of the triangle ABC are correspondingly equal, and therefore by AAA similarity criteria, triangle ADE is similar to triangle ABC, and that is what is the proof of this particular example. So try to understand this. Is slightly different, typical. So try to understand the procedure method of proving this particular example. Now coming to the next example, we are given a triangle ABC. ABC is a triangle. AD and CE are altitudes. They are perpendicular. AD is perpendicular to BC and CE is perpendicular to AB. Now we have to prove the first one, triangle AEP. This triangle, small triangle AEP is similar to triangle CDP, small triangle here again, CDP. We have to prove these two triangles are similar. So let us understand this proof first, then we will go further. Now let us take triangle AEP and triangle CDP. Now we find that angle AEP is 90 degrees and also CDP is 90 degrees. So one angle of both the triangles are equal. Now triangle APE and DPC are vertically opposite angles, so second angle is equal again. And the third angle automatically, that is PAE and PCD are equal because third angle. So three angles of the triangle AEP and triangle CDP are correspondingly equal. Therefore these two triangles are similar, and that is what is the proof of the first example. Now coming to the second example, triangle ABD, we have to show that similar to triangle CBE. So ABD and CBE, we have to show them to be similar. Let us understand. Let us take triangle ABD and triangle CBE. Now first of all, angle ADB is 90 degrees, and so also CEB is also 90, so that is 90 degrees, that is given already by construction there, or because they are altitudes. Now angle B is equal to angle B because it is common to both the triangles. Angle BAD, this angle, third angle, is equal to angle BCE, that is the third angle. Therefore the three angles of the two triangles are correspondingly equal. By AAA similarity, triangle ABD is what you call similar to triangle CBE. So that was the second proof. Now coming to the third example, triangle AEP, this triangle again, small triangle, is similar to triangle ADB, this big triangle. So APE and ADB, you have to prove they are similar. Now let us go to the two triangles there. In triangle AEP and triangle ADB, angle AEP and ADB 90 degrees, that is correct because of the altitudes there. Angle A is equal to angle A common. Angle APE and ABD is the third angle. So the three angles are correspondingly equal. By AAA similarity, triangle AEP is similar to triangle ADB. That is the third one. Now the fourth one is triangle PDC. Triangle PDC, the small triangle here, and BEC, big triangle here. We have to show them to be similar. So let us see how they are similar. In triangle PDC, angle PDC is equal to angle B is 90 degrees, and so also angle BEC is 90. So one angle is equal 90 degrees. Angle C and angle C, that is common, so it is a common angle. And DPC, this small angle here, is equal to EBC, so third angle. So three angles of the triangle PDC and BEC are correspondingly equal, and therefore by AAA similarity the two triangles are similar, that is triangle PDC is similar to triangle BEC. So all these examples are based on AAA similarity, so please understand and learn them. Now coming to the next example, we are given a parallelogram ABCD. ABCD is a parallelogram. AD is extended, this AD is, the side AD is extended to E, and B is joined, and B cuts DC at F, it cuts at F, CD at F. Now we have to prove that triangle ABE, this big triangle, ABE is similar to triangle CFB, this small triangle. So we have to prove that ABE is similar to CF and B, that is smaller triangle. Now let us see how it is possible. In triangle ABE and triangle CFB, angle 1 is equal to angle 2. Angle 1 is equal to angle 2, but natural because AE is parallel to BC because it's a parallelogram, and BE is the transversal, therefore interior alternate angles are equal, therefore angle 1 is equal to angle 2. That is the first point. Angle 4 is equal to angle 5. See, these two, they are corresponding angles because AB is parallel to DC. But angle 4 is equal to angle 3 because they are vertically opposite angles of the parallelogram, and but natural, angle 3 is equal to angle 4. So 4 is equal to 5 and 4 is equal to 3. Please remember this. So 4 is equal to 3 and 4 is equal to 5. And mind you, angle 5 is equal to angle 3, again interior alternate angles. So therefore angle 4 is equal to angle 3. So that is the second important point. Now angle 6 is equal to angle 7. Angle 6 is equal to angle 7, and that is the third angle because angle 1 is equal, please understand, angle 1 is equal to angle 2, angle 3 is equal to angle 5, and angle 3 is equal to angle 4. Two angles are already equal, so but natural, the third angle will automatically equal. So angle 6 and angle 7 are also equal. So the three angles of the triangle ABE are correspondingly equal to the three angles of the triangle CBF or CFB, and therefore by AAA similarity criteria the triangle ABE is similar to triangle CFB. Again by AAA similarity, the thing is we have to identify the three important corresponding angles which are equal, and therefore we can prove them by AAA similarity criteria. Now coming to the next example, we are given a triangle ABC. ABC is given here, and AMP, two triangles are given, and they are two right triangles. See, ABC is one right triangle and AMP is another right triangle. That means angle B and angle M are 90 degrees. Now we have to prove that triangle ABC and triangle AMP are similar, and also we have to prove that CA by PA, that is CA by PA is equal to BC, BC by MP. So let us see how to prove that. Now in triangle ABC and triangle AMP, ABC and AMP, angle B is equal to angle M 90 degrees, that is 100% given to us. Now angle A is equal to angle common to both the triangles. So one angle is 90, okay, both are having 90 degrees angle, and also we have the angle A as common, so two angles are already equal. Now automatically the third angle, that is angle C and angle P, are equal. So therefore the three angles of the triangle AMP and the three angles of the triangle ABC are correspondingly equal. Therefore by AAA similarity criteria the two triangles are similar, that is triangle ABC is similar to triangle AMP. Now triangle ABC is similar to triangle AMP, we have already proved here. Now corresponding sides are proportional, that means AB upon AM is equal to BC upon MP is equal to AC upon AP. Therefore AC upon AP is equal to BC upon MP, or CA by PA, because I have just by interchange the letters here, AC becomes CA, AP becomes PA, so CA by PA is equal to BC by MP, and that is what is the proof expected of us, and we have proved it. So see, that is how we prove the given example. Please learn it. Now coming to the next example, that is the 10th example, we are given a triangle ABC, that is triangle ABC, and also we are given triangle EFG. Two triangles are given, and they have told us that triangle ABC is similar to triangle FEG. That means these two triangles are similar. Triangle ABC is similar to triangle FEG. They are similar. CD and GH are angle bisectors of the angles ACB and EGF. Okay, these are angle bisectors. CD is angle bisector of angle C, and GH is angle bisector of angle G. Now we have to prove CD upon GH. CD upon GH is equal to AC upon FG. FG is here. And also we have to prove triangle DCB is similar to triangle HGE, triangle DCA is similar to triangle HGF. So let us understand here, there are three important proofs we have to give. So let us go one by one. Now in triangle ACD and FGH, ACD, this triangle ACD, okay, ACD and FGH, so the top triangle, the shaded triangle, ACD and FGH, the shaded triangle, I have to consider that. Angle A is equal to angle F, because they have given these two triangles are similar, and when we compare the similarity, we find angle A is equal to angle F. Already it is given to us because the two triangles are similar, corresponding angles are equal. Now angle ACD is equal to angle FGH. ACD is equal to FGH because angle C is equal to angle G, because two triangles are similar, and the angle bisectors divide the given angle, that is C and G, in into two equal angles, and therefore angle ACD and FGH are both equal. Second part, and that is the second angle. Now coming to the angle ADC and angle ADC and angle FHG are the third angles. So therefore three angles are are equal, and therefore triangle ACD by triple similarity, triangle ACD is similar to triangle FGH. Now since they are similar, the corresponding sides are proportional, therefore AC upon FG is equal to CD upon GH is equal to AD upon FH, or CD upon GH is equal to AC upon FG, AC upon FG. So CD upon GH is equal to AC upon FG, and that is what is expected of us, and we have proved it. Now coming to the second part of it, that is we have to prove triangle DCB is similar to triangle HGE. DCB, this triangle, okay, unshaded triangle, is similar to triangle HGE, that is unshaded. So two unshaded ones we have to prove now. So let us see how to prove that. Angle B is equal to angle E. It is given to us. There two triangles are similar, the corresponding angles are equal, therefore angle B is equal to angle E. Angle BDC is equal to GHE, okay, and BCD is equal to angle EGH, because GH and CD are angle bisectors of the same two equal angles, and therefore the two angles are equal. And here angle BDC and angle GHE form the third angle, and therefore the three angles of the triangle DCB are correspondingly equal to the three angles of the triangle HGE, and therefore by triple similarity the two triangles are similar. Now again the third important part, that is triangle DCA and triangle HGF. Triangle DCA and HGF, triangle DCA and triangle HGF. Now we have to prove them as similar. Angle A is equal to angle F, given angle DCA and angle HGF are equal because angle C is equal to angle G, therefore it is angle bisector, both are equal. Angle CDA is equal to angle FHG, angle CDA and FHG are equal, and that is the third angle. Okay, that is the third angle. So by triple similarity, again here the two triangles are similar, therefore triangle DCA is similar to triangle HGF. Now what I suggest is, please go through these examples step by step, understand each step and find out those the three conditions for similarity. Either the three corresponding angles are equal or three corresponding sides are proportional. So find them and identify them and check why the similarity exists, and if it exists, then that is how the proof is given. So now coming to the next example, that is example number 11. So let us see how it is proved. Now we are given a triangle ABC, and ABC is given as an isosceles triangle. That means AB and AC are equal. E is a point on side CB which is extended or produced further, and EF, please understand here, EF is perpendicular to AC. AD is perpendicular to BC, EF is perpendicular to AC, and E is obtained by extending CB further, and it is produced, and we get the point E there. And now we have to prove that triangle ABD, the shaded thing, triangle ABD is similar to triangle ECF. So the shaded one and the unshaded one, we have to prove them to be similar. Let us see how to do that. In triangle ABD and triangle ECF, angle F is equal to angle D. Angle F is equal to angle D, but natural 90 degrees because they are perpendicular to each other. They are perpendiculars drawn. Then angle F is equal to angle D is 90 given. Angle B is equal to angle C. Angle B is equal to angle C because the sides AB and AC are equal. It is triangle ABC is an isosceles triangle. AB is equal to AC, and the angles opposite to them are equal. Therefore, angle B is equal to angle C. That is the second angle of the two triangles. And but natural, the third angle is also equal. Angle BAD is equal to angle CEF, that is the third angle. So by triple similarity criteria, the triangle ABD is similar to triangle ECF. So that is how the proof is given. So please learn these examples, be thorough with these examples, and then we will proceed with the remaining examples in our next session, that is part 2 of this exercise. Okay, learn these, understand them, note them in a book and practice them. Then further we'll go for the remaining examples because we have to solve around 16 or 18 examples. So let us learn those remaining examples in our next session in the second part of this exercise. Okay, thank you.